Alright, this video is called How to Set Up a KSP Equation. And like we discussed in class today, we're going to have to know how to set up the KSP equation in order to be able to solve for the solubility product constant. Okay, so solubility product constant. The first thing we have to know how to do is to write the formula for this. And we use KSP to represent solubility product constant, and these are for ionic salts. So therefore, a metal and a non-metal salt dissolved in water. And we usually write KSP formulas for things that only dissolve slightly in water. Okay, so we know that the formula takes this form. Bracket AX to the A, bracket BX to the B. Now we know that brackets mean concentration, and that concentration is always measured in molarity or moles per liter. Okay, but we have to know what the A's and the B's come from. The A's and the B's have to come from how the solution ionizes in water. So we're going to look at a couple of different examples to see when we would use those. So here's our first example. Our first example is silver acetate, AgC2H3O2. And one of the things that we have to know first is we have to look at it and say, okay, well, Ag is the metal. C2H3O2 is actually a polyatomic ion. It's on the back of our periodic table. And so we know that that is set as one compound. So when we break that up, we're going to get that we have one Ag and one C2H3O2. So my A is going to be 1, and my B is going to be 1. Well, I know from math that any number times itself or raised to the power of 1 is still the same number, so I don't have to worry about them. So I'm just going to say the concentration of Ag times the concentration of C2H3O2 is going to be my solubility product constant. So I'm going to plug in X to represent the concentration. Now we'll see in a later video that X or concentration is given to us in the problem, or the ability to get that will be given to us. But we're just going to plug in for X right now. So we're going to have X times X, and I know that X times X is going to be X squared. So the KSP basic formula for this situation is going to be X squared. So anytime I have a compound that ionizes into single elements or single compounds is going to have KSP of X squared. Let's look at another example. The other example I could have is something like PbCl2. Well, when PbCl2 ionizes in water, I get one lead atom for every 2 Cl atoms. Well, the 1 I know is not going to matter, but the 2 will matter. So I'm going to have to put the 2 on the inside and the outside of the bracket. So I have that written here, Pb, and then you'll see that I have 2Cl2. So when I plug X in for both Pb and Cl, I have X and then 2X squared. So when I simplify that, I have X, and then I have 4X squared, because the 2 is squared and the X is squared. So I have X times 4X squared, which gives me 4X cubed, or 4X to the third. Just kind of as another way to look at this, if I see that I have 2X squared, it's the same as saying X, 2X, and 2X. So X times 2X would be 4X to the third. 1, 2, 3 X's, and then 2 times 2 gives me 4. Okay, so let's look at my last situation. My last situation is if I have AuBr3. And this is just a made-up compound, but if I had gold tribromide, I would have 1 Au plus 3 Brs. 1 Au plus 3 Brs. Okay, so when I go to write my formula, I would have Au, and then the concentration for there's every 1 Au, there are 3 Brs. So I have to have 3 on the inside and 3 on the outside. Au, 3 Br cubed. I plug X in for both Au and Br. So it's X and then 3X cubed. X and then 27X cubed. The most common mistake is people are going to put a 9 right here because they're going to say 3 times 3, but it's not. It's 3 to the third power. 3 times 3 times 3. And so 3 times 3 times 3 gives us 27. So 27X cubed, and when I multiply the X, 1X here and the X to the third here, I get 27X to the fourth. Another way to look at it would be X and then 3 3X's. 3X, 3X, 3X. So 3 times 3 times 3 is 27, and then there are 1, 2, 3, 4 X's. Here's something interesting to look at. If they each ionize into a single compound, I'm going to end up with X squared. If they ionize into 3 parts, I'll end up with 3. If they ionize into 4 parts, I end up with a 4. So 1 and 1 give me 2. 1 and 2 give me 3, 1 and 3 give me 4. And that's just kind of a quick way to double check and make sure that you got it right. So again, remember, for solubility product constant, or KSP, the formula is A times X to the A, B times X to the B. Remember that this X within the bracket, it means the concentration, which is measured in molarity, and that the A's refer to how many parts it ionizes into. If it ionizes into just one part, then we don't need to use that. But if it ionizes into multiple moles per mole, like this, 1 to 2, then we have to put the 2 on the inside and the outside and follow out our problem.